In this video, we are going to learn one last method for finding zeros of polynomial equations and functions. So far, we can find the roots to any polynomial as long as some of them are rational. We have the rational roots theorem, so if we see a polynomial, we can make a list of possible rational roots, try synthetic division until we find one that works, and then use that synthetic division to get to the quadratic, and that's how we find the two imaginary roots. What about when none of the possible rational roots work? If we look at this one, number 5, x to the fourth plus x squared minus x, you can tell by looking that the possible rational roots there are 1, 2, 3, and 6, both positive and negative. We could try all 8 of those possibilities, but it's not going to work. Here's the graph of it. You can see there are 2 real roots there, but those 2 roots are irrational numbers. Now, you might recognize that irrational number, but let's pretend we don't. So, the rational roots theorem isn't going to help me. Synthetic division isn't going to help me. I need something else. Well, sometimes, and I'll admit this doesn't work all that often, but sometimes, what you can do is think of the quartic function that we're looking at as if it were a quadratic. This is a very cool trick, and it sets you up well to do some very important stuff in calculus. What we'll do is say, that first term, x to the fourth, is the square of the second term, x squared. And so I can rewrite x squared as some other letter. Usually we use a or u. I'm going to use u, because that's what you'll use in calculus. Doesn't really matter what you call it. But if x squared is u, then u squared would be x to the fourth. Which means we can do some substitution here. We can take this x to the fourth and rewrite it as u squared. We can take the x squared and rewrite it as u. And the minus 6, we don't need to substitute it at all, because that's still minus 6. And we can find the solutions to this quadratic by solving for u. This is going to work as long as the first term, or the variable part of the first term, is the square of the second term. That's all we need. So it works for x to the fourth and x squared. It could work for x to the sixth and x cubed, or x to the 10th and x to the 5th. As long as the first term is the square of the second term, we'll be able to make it into a quadratic, and then we can solve. This one happens to solve by factoring. If it didn't, we could complete the square. We could use the quadratic formula. This is u plus 3 times u minus 2. And what we're going to do is solve for u, and then turn that into solutions for x. So u equals negative 3, or u could equal 2. The question is not asking me to find values for u. Remember, we made up that u. It's not really a part of the problem. So what we're going to do now is substitute back in that x squared for u, and then solve for x by taking the square root of both sides. And so x is either plus or minus the square root of 3i, or x could be plus or minus the square root of 2. And if we look back at our roots here, these 2 roots, 1.414 and negative 1.414, those are the square root of 2 and the negative square root of 2. You might recognize that number 1.414 as the square root of 2. If not, that's okay. But notice how we will not see the plus or minus 3i on the graph because they're imaginary. They don't show up anywhere on the graph. So you can just write this as one final little solution set. And that would be our answer all in one place. Notice how we are expecting 4 answers, so we got 4 answers. We'll do this for the next one also. And this time, though, as we go, we're going to write down what we're doing. So the first thing to do is, just like always, we're going to empty out one side. And so we'll move that. I like to keep the lead term positive, so I'm going to move everything else over. And then we're going to recognize the pattern that we're looking for, that this x to the 4th is the square of x squared. That's what we need. So we will declare our u and our u squared. And so we'll say that u is equal to x squared and u squared is equal to x to the 4th. And then we will rewrite as a quadratic. This only works if the first term is the square of the second. Well, that's what we have here, so we can turn this into u squared plus 13u plus 36 equals 0. And now we will solve for u. This one, again, factors. I'm not sure why I was so kind both times today. To u plus 9 times u plus 4. And make sure you're actually doing all the work on this. Split and solve. Don't take shortcuts here. So our solutions for u are u could be -9 or u could be -4. And then we will substitute x squared back in. And so that's where our u becomes x squared. And now that we have the x back in, we can solve for x. Usually this just means taking the square root of both sides. Not always, there could be something else going on. But generally speaking, all that we're going to have to do is take the square root of both sides. And then our solution, plus or minus 3i, or plus or minus 2i. And so that is our final answer. One quick note about these problems is that it doesn't only work for polynomials. There's another type of problem where it works too. In fact, any time where we have the square of the first term is the square of the second term, it'll work. So this is not a polynomial. But we can still say that x is the square of root x. So we can do our u substitution here. U can be the square root of x. U squared would be plain old x. And so our function would then be u squared minus 6u minus 7. And we can find the zeros of that. This one also factors. I've been very generous today. And so we can split and solve that. U minus 7 equals 0. U plus 1 equals 0. U equals 7. U equals -1. So we did our substitution. We solved for u. Now we're going to put the x back in. It's not, sorry, I was about to put back in x squared, but that's not what it is. It's not putting back in x squared. We should be putting back in root x, because that's what u is. So root x equals 7, or root x equals -1. And unlike before when we had x squared, so we had to take the square root of both sides, here we'll square both sides and get that x equals 49. On the other side, though, if you square both sides, you'll get x equals 1, but that's not true. The square root of 1 isn't equal to -1. So you should notice here that this does not lead to a solution. The square root of x can never equal -1, so we will not get a solution out of that. If you want to think of it as squaring both sides and then getting x equals 1 and thinking that as a possible solution, that's fine, but either way you have to check your solutions. So I will go back to this graph and I will type in the original function we had was x minus 6 times the square root of x minus 7. And our solution was 49, which explains why I don't see it here. And that actually also explains why I don't see it here, as I put the minus 7 in the wrong spot. And here we can see our solution of 49. And that is the only solution. You can zoom out all you want. Not going to get anywhere. That's the only solution.